we will continue. Here we want to arrange the compounds according to their thermal stability in ascending order. Okay, we will start with the first one with more heat content. So we will start with the first hydrogen fluoride. Hydrogen fluoride has delta heat content or heat of formation greater than any1. So by decreasing the value of heat content of formation, the thermal stability increase. How thermal stability increase? Okay, thermal stability increase as exothermic reaction coming with a negative sign. So we have here hydrogen fluoride, hydrogen bromide, and hydrogen chloride. Okay, but the greatest one in the heat formation neglected the negative sign. Okay, hydrogen fluoride, and the less than it we have hydrogen chloride, and the last one hydrogen bromide. The end of them hydrogen iodide, as it is an endothermic reaction, as it is unstable or dissociated spontaneously at the end of reaction. Okay, after that we have the following equations. What we want to know, we want to know which of them express the chemical reactions that occur, happen, and actually happen. Okay, we said that the reaction happen in the forward direction. So the more stable will be the higher stability that making the direction of the reaction. Heat of formation of Medini note, knowing that heat of formation of SO2 gas negative 296.83 kilojoule per mole, and SO3 gas is negative 395.72 kilojoule per mole. So the highest one in the heat formation is sulfur trioxide gas. Sulfur trioxide gas, as it coming in the forward direction, as it has the coming in the stable state. So the first one equation of sulfur dioxide plus oxygen gas forming sulfur trioxide is the true equation, or coming in the actually happen in the nature, or happen due to heat of formation. Okay, we will start or end our unit by HESS law. HESS law means that all reactions, okay, we will summary HESS law as it is the same like first law of thermodynamics as law of conservation of energy. So here we have all rules are the same in heat content. So HESS law, constant heat summation, make the reaction in isolated conditions. Here we have a mixture of reactant and product. Some reaction happens slowly, like oxidation of iron or iron rust. It take a long time. Okay, some of reactions take we can't do it in the presence of in the lab, as it is a dangerous for making it. And the last one, difficult to measure the heat of reaction in normal condition of pressure and temperature. So we have here HESS law that can summarize or make summation for this reaction. At the end, we said that HESS law is one of the forms of first law of thermodynamics. Why? Why? Because it considers chemical reaction as isolated system, has heat is a constant amount. Also, we can consider it as algebraic equation. Why? We can add it or subtract. Okay, if we subtract, we will reverse the reaction. So the product will be reactant and the reactant will be product. Okay? At the end, the mathematical relation of HESS law, it means that delta H equal delta H1 plus delta H2 plus delta H3. How we can calculate the heat of content of reaction? Okay, we have here the reaction of A plus 3B forming 2D. Okay, we have here two steps that forming the reaction. The first one, A plus 2B, step 1, forming C. And we have delta heat or delta H plus any number. The second equation, C plus B, step 2, forming 2D. Delta H2 plus. Okay. When we make adding to the two equations, A plus 2B plus C plus B, the first, all the reactant, okay, and the other side have C plus 2D, the two products. Okay, from the two sides, we will neglected C. At the end, we have A plus we sum 2B plus B forming 3B, forming 2D. At the end, delta H equal delta H1 plus delta H2. Okay? We have here a lot of examples calculating heat of formation of carbon monoxide gas according to the reaction. We have the end of reaction. We want to get this one, carbon in the solid state plus have oxygen mole or have O2 give CO. Okay, we have two thermal equation here, carbon plus oxygen forming carbon dioxide, and its delta H1 equal negative 393.5 kilojoule per mole. Carbon monoxide plus have O2 forming carbon dioxide with delta H2 equal negative 283 kilojoule per mole. Okay, by subtracting 2 from 1, we get, or we multiply, as we said, we will multiply the first one, the second one time negative 1. Again, we will multiply the second equation by negative 1. So we get, okay, carbon plus oxygen negative CO2 negative have O2. It will get CO2 minus CO2. Okay, this side will be neglected. All positive and negative neglected. Okay, the other one, we have C plus O. O minus have O. It will give plus O here. Okay, and we will transfer carbon monoxide to the other side of the equation, to the right side. Okay, we will get carbon monoxide here, and we will make subtraction for delta H1 minus delta H2. It will get negative 393.5 negative 283, and we get at the end delta H for all of this reaction negative 110.5 kilojoule per mole. Okay, another equation or another problem, how we can calculate the heat of combustion of nitric oxide NO. Okay, I want to make a combustion of it according to the reaction of NO plus have O2 produce NO2 gas. Okay, the first one, we have two equations, have nitrogen gas plus have oxygen gas give nitrogen monoxide and delta H1 of it plus 90.29 kilojoule per mole.